Welcome to Baker Oil Tools Introduction to Liner Systems. In this demonstration, you will learn about some of the basic equipment and techniques used in a typical liner installation. There are many variations appropriate for a wide variety of applications. When a prospective target is identified, the operator will select a surface location that the reservoir can be effectively drilled from. The drilling rig and associated equipment will be moved in and rigged up. First, the large diameter conductor pipe is driven into the ground, or alternately, open hole is drilled and the conductor casing is run and cemented conventionally. This pipe must be sized to accommodate all subsequent hole and casing sizes which are required to reach the target producing interval. The surface hole is drilled with a bit that is slightly smaller than the inside diameter of the conductor casing string. This hole is normally drilled to a point below the deepest known potable or drinking water layer. Mud is circulated to clean the drill cuttings from the well, and the bit is pulled out of the hole. Surface casing is then run to cover the entire open hole and the previous conductor casing. When the surface casing has been landed in the wellhead at the surface, clean drilling mud is circulated to ensure that all the cuttings and excess mud cake has been removed from the open hole. When the mud returns are clean, cement is mixed and pumped down the inside of the casing, out the shoe at the bottom, and up the annulus, or the space between the outside of the casing and the open hole. Special rubber plugs are used to separate the cement from the displacing fluid and to wipe the inside of the surface casing free of cement. The lead plug in front of the cement lands on a baffle plate near the shoe and ruptures to allow cement to be displaced into the annulus. The operator may choose to cement the entire surface casing to ground level or only a portion of it. When the second plug bumps at the end of cementing, a pressure increase will be seen and the pumps are shut down. Until the cement sets up, pressure must be held on the inside of the casing to prevent the heavier cement from U-tubing back inside. Once the cement hardens, the next hole size can be drilled. After drilling out the shoe, the operator will perform required pressure testing to verify integrity of the cement job, as well as formation stability. The next interval of open hole is then drilled. If required, open hole logs may be obtained on wireline, followed by a cleanup trip to verify that the hole is in good condition to run casing. Since the surface casing was run relatively deep, the operator has decided to install a production liner rather than running a casing string all the way from surface. The liner assembly which is run is made up of liner casing and specialized equipment provided by an oilfield service company. Because it is critical that the components work in conjunction with one another, one manufacturer will normally provide all of the saleable and downhole rental equipment for a job. The first section of liner to be run is referred to as the shoe track. The components are typically thread-locked together to ensure that they may be drilled out later without breaking connections and unscrewing from the liner. The bottom of the liner is the float shoe, which performs two important functions. The shape of the shoe helps to guide the liner through the casing and open hole. Single or double check valves prevent backflow of fluids into the inside of the liner. A ported baffle ensures that balls or plugs inside of the liner cannot foul the float valves. The landing collar also performs two functions. First, a ball can be landed on the shearable seat to allow differential pressure to be applied to hydraulically actuated tools above. Increasing the pressure will shear out the seat and restores the circulation path. Additionally, the collar ensures a specific stopping point for the liner wiper plug by providing a sealing and anchoring point when cementing is complete. All shoe track components are normally manufactured to allow sure and rapid drill out later. As the shoe track is lowered into the well, the floats are checked to verify that mud is not backflowing inside. Additionally, the shoe track will be circulated through to verify that there are no obstructions. The required joints of liner casing are made up above the shoe track. Normally, enough liner is run to completely cover the entire open hole plus 100 to 300 feet above the previous shoe track. Since the float valves do not allow the inside of the liner to fill up as it is run, the liner should be filled from the surface to prevent the mud from collapsing the liner casing. When the required number of casing joints have been run, the liner hanger assembly is picked up. For this well, the assembly is comprised of the liner hanger, the drillable pack-off bushing, and the liner top packer. These are the components that will remain in the wellbore and are sold to the customer. Inside of the saleable tools, we also have our running tools, rented to the customer as a part of the liner installation service. The liner setting tool is used to connect the liner to the drill pipe. It carries the liner into the well and provides a reliable releasing mechanism when the drill pipe must be disconnected. The slick stinger is a polished tube that seals inside of the drillable pack-off bushing to create a pressure seal at the liner top during the installation process. The liner wiper plug is attached to the end of the running tool assembly or may be held in a special bushing in the liner casing below the hanger. The plug will be used to separate the cement from the mud later. It is very important that the compatibility of the equipment is verified to be certain that the components work properly with each other and in the customer's well. This is checked initially in the shop when the equipment is loaded out, and then confirmed at the well site prior to running into the hole. Lengths, IDs, ODs, shear pressures, and other important details are recorded in the tool specialist's tally book as a final check. Information entered in the tally book becomes a permanent part of the well record. The hanger assembly is made up to the liner and circulated through to ensure that there are no obstructions. At this time, the rig crew will rig down the casing handling equipment to run the liner into the well on drill pipe. With the liner full of mud, pick up and slack off weights are recorded. The weight of the liner should be close to the calculated weight with the proper buoyancy factor applied. The liner will be run into the hole until the liner shoe reaches the previous casing shoe. Again, we verify that we can circulate and we record the pump pressure. This will ensure that the drill pipe, liner, and annulus are filled with clean mud and hydrostatically balanced. From this point forward, the liner will be running into the open hole, where all operations must be carried out as efficiently as possible. Pick-up and slack-off weights are determined, and the liner is run into the open hole. Bottom is located by observing a repeatable drop on the weight indicator. The liner is picked up off bottom, and the well bore is circulated clean to remove any cuttings from the annulus. At the surface, special equipment has been rigged up on top of the drill pipe, which will be used to perform important operations during the cement job. Because the hydraulic set liner hanger requires differential pressure to activate, we will drop a ball from surface to pressure up against. When the external handle is unlocked and rotated, the positive ball dropping sub will expel a setting ball into the ID of the drill pipe. The setting ball will be allowed to fall or may be pumped until it lands on the seat in the landing collar. As pressure is applied at the surface, the hydraulic cylinder of the hanger shears and strokes the slips upward until they contact the casing wall. As the weight of the liner is slacked off, the hanger slips transfer the loads to the previous casing string. The liner is now hung with the shoe several feet off bottom. The liner casing is in tension. To regain circulation, the setting ball is blown out by increasing surface pressure to shear the pins in the seat. Circulation is re-established, and the well is circulated until smooth and steady pump pressure is observed. With the liner hung, we are ready to release the drill pipe from the liner. The releasing operation will depend upon the type of setting tool used. The C2 liner setting tool releases by simply rotating the drill pipe to the right about 10 turns. Right-hand rotation disengages the float nut from a special carry-in thread profile in the body of the liner top packer. The drill pipe will now be picked up to verify that the setting tool is released. We expect to only see the weight of the drill pipe on the weight indicator, since the liner is now being supported by the liner hanger. We only pick up a couple of feet, as we do not want to activate our packer setting device yet. Once we have confirmed that the setting tool is released, we slack off and circulate to verify our pack-off integrity. We must slack off enough to overcome upward piston forces on the bottom of the pack-off. Up specialized blending equipment and pressure tests their pumps and surface lines. Once the cement is mixed and the properties are tested, it is pumped down the drill pipe and into the liner. At the surface, the cement is pumped through a cementing line into the TD swivel port. The cement flows around the pump-down plug, which is resting on a flapper inside of a sliding tube. When the required volume of cement has been pumped, the plug lock is turned, the tube drops, and the pump-down plug is forced out of the TD plug dropping head. The flag sub provides visual confirmation that the plug has been pumped down the drill pipe. The pump-down plug follows the cement down hole, wiping the drill pipe and separating the cement from the displacing fluid. As the pump-down plug nears the calculated displacement to the liner wiper plug, the pumping rate is reduced. A pressure increase may be seen when the pump-down plug latches into the liner wiper plug, and the plugs will shear off of the running tool assembly. Displacement continues as cement is pumped out the liner shoe and up the annulus. As the plugs near the landing collar, the pump rate will be slowed again, and the bump will be observed by the increase in pressure. When we are comfortable that the plugs are holding tightly, the pressure is bled off, and we check to see that there is no backflow through the float valves as the heavier cement tries to U-tube back inside the liner. Now that our cement is in place, we are ready to set the liner top packer. To do this, we will pick up the drill pipe, expose the spring-loaded dogs in the packer setting dog sub, and apply set-down weight of the drill pipe. When sufficient weight has been applied to shear the setting pins in the packer, compression will energize the seal element and engage the hold-down slips into the casing wall. The packer is now set and will provide an effective annular seal between our liner and the previous casing string. Before pulling the drill pipe and setting tools out of the hole, it is recommended that excess cement should be circulated out from the annulus above the liner top packer. First, the drill pipe is raised to remove the slick stinger from the drillable pack-off bushing. A light pressure test may be performed to verify that the liner top packer is sealing if desired. Since the pack-off is not sealing, circulation at the liner top will remove excess cement from the drill pipe annulus above the packer. When the returns from the annulus are clean, circulation is stopped. And the running string is pulled from the hole. At surface, the setting tools are cleaned and their condition is checked before preparing them for return shipment to the district. The customer's well now has a newly cemented liner in place, hung off from the previous casing string and with an effective annular seal. It will be ready for production or drilling ahead after the cement sets up. This completes the demonstration of installing and running a liner system. Please contact your local Baker Oil Tools representative for additional information or visit our website at www.bakerhughes.com/BOT.